Hello to all my pre-calc kids. So today we're going to go over the practice test for the rational functions graphs, which covers section 4.2, 4.3, and 4.4, which is inequalities. So hopefully I can give you a little tips and tricks before we start, just so you know that all of this information you are able to do. The domain of a rational function, whatever makes the denominator equal to 0. That's where we don't want whatever makes the denominator 0, that's where our domain can't be. To find the x and y intercepts, to find the y-intercepts, plug in 0 for x. To find the x-intercepts, set the numerator equal to 0 and solve. Vertical asymptotes you get from your denominator, where that's 0. You also get that from your domain. Horizontal asymptotes, we have 3 cases. And let's just give those to you right now. With horizontal or slant asymptotes, 3 cases. First case, if the degree of the numerator is smaller than the degree of the denominator, then, that's a little arrow just in case you need it, then we will always write y equals 0. You need to write y equals 0 because this is the equation of a horizontal line. Second case, we look at the degree of the numerator, and if it's equal to the degree of the denominator, then we write y equals, this will be a horizontal. The first 2 are horizontal. We write y equals, and then we take the leading coefficient of the numerator, divide it by the leading coefficient of the denominator. There's a third thing that we have to do. There's a third case. If the degree of the numerator is larger than the degree of the denominator, then we have to do long division or synthetic division to see what equation we get. This is most likely where you're going to get a slant asymptote. So let's look at the problems that I gave you and see what we can come up with for a graph. Because in the end, we want something that's graphable. So I'm going to draw my graph right here, and I'll draw it for the second problem too. Okay, so step 1, factor everything. I have x minus 3 on the top, and I have x minus 3, x plus 3. Interesting that we have a problem on the practice test that's similar but different to what we did in class, and I'll go over that in a second. Notice just for us that x minus 3 is on the top and x minus 3 is on the bottom. So in our domain, x cannot equal 3, x cannot equal negative 3. What makes the denominator 0? Well, since we didn't write y or x cannot be 0, I can find my y-intercept. If I plug in 0, I get 9 over negative 9. So my y-intercept is at 0, negative 1. I'm going to go over to my graph and plot that point. All right. Already found one thing. Next up, we want to find the zeros. I want to find the x-intercepts. So I'm going to take my, now this is what we need to do. We look at our equation and we can simplify it. We can cross off the x minus 3 on the top, the x minus 3 on the bottom. What is the only thing left on the numerator? I have 1x minus 3. I set it equal to 0. So I have x equals 3. And go 1, 2, 3. Well, look, I should have an x-intercept at 3, but I wrote that x cannot equal 3. So when we get something like this case, we put an open circle there. That's called a hole. I'm just going to write that in a different color. That's where a graph cannot exist. Okay, well, we found where our x-intercept is, so let's test out what happens at x minus 3. So wherever I see x minus 3, everything else I'm going to plug in positive 3. So I have x minus 3 over 3 plus 3, which gives me a positive slope. So right here, my graph's going up. Put that on my graph. Next, I want my vertical asymptotes. So my domain, I already have x cannot be 3. So my only vertical asymptote is going to be at x equals negative 3. 1, 2, 3. And I'm going to put that on the graph. To find the horizontal or slant, I look at the degree of the numerator. I have degree 2 on top, and I have degree 2 on the bottom. Because those degrees are equal, I'm going to have a horizontal asymptote at y equals the coefficients. There's a 1 in front of the x, 1 in front of the x. So y equals 1. So I'm going to put that on my graph. Go up 1 and a horizontal line through it. The last thing I need is to create my number line. And my number line is all of the key points that occur along the x-axis. So I have negative 3, and then I have positive 3. And you'll see what happens. If I plug in a number to the left of negative 3, I could either plug it into the fully factored, or I could plug it into the simplified equation, x minus 3 over x plus 3. I can plug it into the simplified equation because whatever I get on the top, I'm still going to get the same in the bottom. They cancel out. So let's pick negative 4. Negative 4 minus negative 3 is negative 7. So that's negative. Negative 4 plus 3 is also negative. So I'm going to get positive values to the left of negative 3. So I look at my graph. Where is my graph going to be positive left of negative 3? Either up here or down here. Positive would be above. So I put my end behavior in. My graph goes up. How about between negative 3 and 3? Well, I noticed that 0 I can plug in. So let's plug in 0. I get a negative 3 over 3. That's negative. So that means here I'm going down and I'm coming up. I go through my 0 and I'm going up to 3. So that kind of gives me my point. Then I reach my hole at 3. So let's pick a number to the right of 3. How about 4? 4 minus 3 is positive. 4 plus 3 is positive. So my numbers are positive. And look, the numbers between 0 and 1 are positive. I found the domain, the x and y intercepts, the vertical asymptote, the horizontal asymptote, Does the graph cross at any asymptotes? Does not cross here. Is there a hole? Yes, there is a hole at x equals 3. And then we have our number line. Let's try one more and see what we get. Step 1, always factor the rational function. So I have x minus 3, x plus 2. So that gives me my domain. X cannot equal 3. X cannot equal negative 2. Did I just write x cannot equal 0? Nope. So I plug that right in. So for the y-intercept, I have 0 over negative 3 times 2. So I have my y-intercept at 0, 0. So let's graph that. Next up, my x-intercepts, my zeros. What am I going to do? I take the numerator, set it equal to 0. So my x-intercept is at 0, 0. Already got that, so I'm done. Next up, vertical asymptote. What makes my denominator not equal to 0? Well, we already have it done. So I write x equals 3, x equals negative 2. Graph those. 1, 2, 3, 1, 2. Horizontal asymptote. Degree of the numerator, 1. Degree of the denominator, 2. If we look back at our cases, the degree of since the denominator is bigger than the numerator, we're going to write y equals 0. And I'm going to graph that for you, hopefully in a visible fashion, right along the x-axis. So the last bit that we have to do is our number line. What are the key points along the x-axis that we have to test? Well, we have negative 2, we have to test 0, we have to test 3. So if we look to the left of negative 2, if we plug in negative 3, we get negative, negative, negative. 3 negatives, so that would be negative. So what does that mean for our graph? Is it going to be above the x-axis or below? Negative means below, so we're going down here. Connect the dots. Next test, between negative 2 and 0, let's plug in negative 1. Negative, negative, positive. So I have positive numbers. That gives me my end behavior here going up. And I want these y values to be positive until I get to 0. Well, let's pick a number to the right of 0, between 0 and 3. How about 1? Positive, negative, positive. Gives me negative. So what does that mean? I'm going down this way. So I have to connect my graph. And in between, it looks like a chair. Last bit, to the right of 3, 4, positive, positive, positive. So that means we're going positive here and positive here. And if I gave myself more room, these two quadrants look the same. We can cross our horizontal asymptote in the middle, because horizontal asymptote and slant asymptote are looking for end behavior. Now let's flip. Let's go to the next part. Given the graph, state the domain, the x and y intercepts, the vertical asymptotes, the horizontal and oblique asymptotes. So let's just look at the dashed lines here. Our domain, where are the places that x cannot be? Well, it looks like, to me, x can't be 1, 2, 3. X cannot equal -3, and it can't be 1, 2. Oh, sorry. This looks like -2, x to not be +2. There's my domain. How about my x-intercepts? Well, it looks like it doesn't cross the x-axis here. It crosses the x-axis at about -1/2. So I have -1/2, 0, nowhere else. And then it crosses right about at 1.5. So I have 1.5, 0. So there's my x-intercepts. My y-intercept? Well, let's see. Where does it cross? Right there. So this is at 0, let's call that 1/2. My vertical asymptotes, these vertical dashed lines happen at x equals 2, x equals -2, just like our domain, these match. And my horizontal asymptote, where is this at? Y equals 1. Just pulled this information right from the graph. If we try one more, our domain, where can't x be? Where is our vertical asymptote? It looks like it's at -4, so x cannot, or sorry, +4, so x can't be 4. Next up, x-intercepts. Well, where does it cross? So it looks like our graph crosses right here. So let's call that 1/2. Did it cross anywhere else? Nope, we're done. Our y-intercept looks like this crosses right at about 0, maybe a little lower, but for our purposes, let's write y equals 0. Vertical asymptote. What is the equation of this vertical line? It should be x equals 4. For our horizontal asymptote, what is the equation of this horizontal line? That looks like it's at about 1, 2, let's call it 2. So our horizontal is y equals 2. We can pull all of this information if we have a graph. Piece of cake. Last part of your test. Solve the inequalities. This is basically what we're doing before, only we don't have to graph. All we need is the number line. So what makes this 0? Well, x equals 0, x equals 2, x equals -4. Once we have those, draw our number line, put these on the number line in order. So -4, 0, 2. Now we test points. So pick a number left of -4, -5, negative, negative, negative. Between -4 and 0, how about -1? Negative, negative, positive. 2 negatives make a positive, so that's positive. Between 0 and 2, let's try 1. So positive, negative, positive. That makes it negative. And to the right of 2, positive, positive, positive. So this question is saying, where is this function less than or equal to 0? Where is this function negative? So my solution should be written in interval notation. So my solution should be from -∞ to -4, and we're including -4, so we write a bracket. Union, we're including 0 and we're including 2. So we write bracket 0, 2, bracket. If this was a less than sign, we would be using parentheses. Next up, last question. How do I find what makes this 0 and what this can't be? So I have my domain is x cannot equal -2. Put that on the number line. I have a 0 at x minus 4, so x equals 4. Put that on my number line. I have all the information that I need. So I plug in a number left of -2, so -3. Negative, negative, positive. Between -2 and 4, how about 0? Negative, positive, that makes this negative. And to the right of 4, positive, positive. So again, I want numbers that are greater than or equal to 0. So where is this positive? From -infinity to 2, -2, bracket, union, bracket 4 to infinity. Hopefully this has been helpful. Email me if you have any questions, and I'll go over anything in class on Monday. Have a great day.